Hello everyone, thanks for having me. I'm Nithin. I'm here to talk about the Nemotron speech family of models and how they are built, especially for handling the robustness. And today I'm gonna go over who we are, what we do, what are the models we built, and how we build them, especially for handling the noises, and how our models are better in terms of like speed, and also how we train them, and why the Far Field ASR Leaderboard is really important. So first, who we are. So we are NVIDIA Nemotron speech team. Our goal is to train state-of-the-art, open production-ready models, and we do it very openly, open data, open models, open weights, and we do train with the open source Nemo toolkit, where you can use it for training, fine-tuning, and running for the speech AI models. Our team mainly works on three model areas: ASR, text-to-speech, and speech LLM, which I'm going to talk about in the future slides. So now I'm going to talk about the Nemotron family of speech models and also various speaker models. The first one is the Parakeet, which is the fast and accurate ASR model. We have two variants of it, English and multilingual in 25 languages. The next class of models I would like to talk about is the Nemotron ASR models. It's the same class as Parakeet with the similar encoder with the cache-aware architecture. It's trained for real-time transcription and multilingual. We just released the Nemotron 3.5 ASR. It handles 40 languages and variable low latency as well. The next class of models is the Canary. It does two things: multilingual transcription and also translation with a greater accuracy across the 25 languages. Canary Quen also falls under the Canary class of models, but it has a LLM backend. We use Quen 2.5 as our first LLM backend for the Canary class of models, and we are working on the next versions of it. The final but not the last model is the streaming short form model. It's really fast, tiny model, and it handles multiple speakers for speaker diarization to know who spoke when. And all these models are open source. Every model is released by CC by 4, so you can download for free on Hugging Face and give it a try if you haven't already. During this talk, I would like to focus mainly on Parakeet class of models. These are the models we designed especially for handling the workloads of everyday use cases on edge devices, cloud devices, and also the desktop class devices. So we wanted to build it especially for this rich ecosystem. So, and we are very happy to see the users finding it really useful. So we saw great attraction for this. Approximately, we are seeing 1 million downloads per month on Hugging Face. As I said, it has rich ecosystem right now. If you'd like to try on Parakeet.cpp, MLX, Onyx, MCP servers, desktop applications, whatnot. So if you haven't already, I highly suggest you to give this model a try. We did release on two versions, V2 and V3, English and multilingual variants as well, especially for the European languages. It was recently featured in the HF Richie mini robot as well, which does real-time speech-to-speech transcription, interactions especially, and Parakeet was also used for transcription. So that shows that the model is really capable of handling real-world use cases. Now, speaking of real-world use cases, it's really important because we want to talk about how these models handle actual noise, or maybe the far field noise, which is really useful for all the agentic stuff these days. Maybe robotics, or maybe when you want to use it in your everyday use cases. We do have OpenASR Leaderboard, which has become the standard for ASR evals, but it has few data sets like eval sets, which are like earnings and AMI, which covers the real world use cases, but it's not close in terms of how we measure for noisy, far field, and real world results. So it's really essential that we need a leaderboard which can handle or which can actually measure and benchmark different models to evaluate on this, especially for distance to evaluate how these models are performing for a far field voice. This is going to be really useful for like drive-through scenarios, and robots for reverberation, etc. If they're living next to you in the room, background noises like HVAC, TV, traffic signals, for example, and all these are really important scenarios which we need to consider, but we kind of like the leaderboard for it. Speaking about the noise, it's really important to build these models for robustness. So for Parakeet, we handle the robustness in two fronts. One is architecture and the data. For architecture, we use the fast conformer encoder and the TDT decoder. TDT decoder is really useful for bringing the robustness to the model. We moved from RN90 for the V1 version to TDT because first of all it's fast, and also helps in the robustness, because along with the token predictions it also predicts the duration, which helps for robustness for the model whenever there is noisy scenarios. And since we use this architecture, we always makes sure that the output tokens are always lesser than or equals to the input tokens, which is the acoustic tokens. So that way there is very less room for hallucinations in the first place. So along with architecture, one more really important factor that played a big role in robustness is the data. And for this, we use the granary data, which is the open and reproducible pipeline that we built for generating these pseudo labels. Granary data was built on open data. It consists of 1 million hours of data, which is multilingual data, 650K hours of ASR data, which is multilingual, and also 350K hours of translation data. This translation data consists of EN2 experts, so across these 25 European languages. With the architecture and the data, we train the Parakeet models, and it really shows up how the model performs under noise. As you can see in this bar charts, when we evaluated on the OpenASR leaderboard, the model really shows its performance even under noisy conditions. As you can see from the clean to SNR of 5, which is really no low signal to noise ratio, the model only struggles by 2.3 percentage points, which shows the model is doing really good. But for this, we used music and additive noises. I'm pretty sure it doesn't cover all the scenarios which we used in real world use cases. And this is where the FFASR leaderboard comes into the picture. And here the Treble Technologies, along with partnership with Hugging Face, has built the leaderboard, which is really useful for benchmarking the models on real-world noises, where maybe the speaker is moving, or different use cases like reverberations and all the different types of noise levels. So over here, it's great to see the Parakeet models ranking 3rd and 4th on the leaderboard. And due to the decision we have taken in terms of designing the Parakeet, the accuracy along with the higher throughput also takes into consideration, and we can see that Parakeet models leads across these both fronts, considering the higher throughput along with the great accuracy. And this far field leaderboard matters really because it helps us for giving the better rewardness for the robustness of the models, and it exposes failure modes like hallucinations and the performance of the models if they're really good on maybe near field data or maybe like the clean data. These leaderboards actually expose us for the real world use cases, and it's realistic. I mean, it considers like various noise and signal to noise ratios levels, so it's really useful for evaluating. And having this leaderboard also helps us to build a next generation ASR models that will be shaped for all the agentic use cases and different speech to speech interactions as well. So I hope this information that we have given on how we build the models is really useful even for you to start taking up these models and fine-tuning. And as I said in the beginning, our goal is to make all the models open. So open data, open models, open toolkit. With the latest version of the Nemo toolkit, we also integrated agentic skills. So if you have the data, you just tell the agent and it should get you started. And of course, more data and more models are coming soon. So stay tuned. Thank you.